Alright, what's up guys? In this video we're going to play with some more calculus here, and we're going to do another integration practice video. So this is going to be example number 19 of the integration practice series here. Alright, let's continue here. So this is a definite integral here from 0 to the square root of 2, and then we have 4 all over the square root of 4 minus x squared integrated with respect to x. So the first thing I always tell students to do is factor out constants. So I'm going to take that 4 out and rewrite it. Okay, so that's the first thing you need to do. Just take out the constant. Don't forget about it, but factor it out at the beginning and deal with it later. Okay, so how do we integrate 1 over the square root of 4 minus x squared with respect to x? Well, hopefully you can see that this is just a clear trig substitution. So I'm not going to go into the whole spiel about trig substitutions. I got plenty of videos on trig substitutions, so please visit my other videos for more detailed explanations. So we need to determine what's the appropriate substitution here. Well, this clearly isn't a tangent substitution, and it's not a secant either. This is a sine substitution because we have the square root of a minus x squared. So remember for sine, and keep in mind that trig substitutions don't have to be under square roots. But in this particular case, we have a squared minus x squared. And remember, when we have that, then we say that x is equal to a sine theta. So this is a sine substitution. So in our case, a here is simply going to be 2. So what we'll have is x is equal to 2 sine theta. And if we take the derivative of that, we get dx. That's 2 cosine theta d theta. So we still got our little 4 that's out there. And notice how I left the bounds blank. We're going to have to change the limits. So we'll do that a little further down. And 1 times whatever the dx is, it's just going to be whatever the dx is. So I'm just going to write 2 cosine theta on top. And then down here at the bottom, I just substitute in all of my stuff. So this would be 4 minus 2 sine theta squared d theta. All right, let's clear up that square root there. Get that part out of the way. So it's just going to be 4 minus, well, that's just going to be 4 sine squared theta, because you're squaring not only the 2 but also the sine. So remember that this is just going to be 2 times the square root of 1 minus sine squared theta, which is just going to be 2 times the square root of cosine squared theta, because remember that sine squared of theta plus cosine squared of theta is equal to 1. So if we wanted to solve that for cosine squared theta, it would be cosine squared theta is equal to 1 minus sine squared theta. And if I take the square root of cosine squared theta, I get cosine theta. So therefore, this just becomes 2 cosine theta. So now we just go back to our integral. So we got 4. I'm going to change the limits here in just a minute. And then what we got is 2 cosine theta all over 2 cosine theta. All of this integrated with respect to theta. And as we can clearly see, this gives us 4. We have our integral, and that'll just leave us with d theta on the inside. All right, so now let's change the limits. Now remember that x was equal to a sine theta, or x is equal to 2 sine theta, excuse me. This was a sine substitution. Now we need to solve for theta, so remember theta here, that's just going to be arc sine, or sine to the negative first, of x over 2. And so to change the limits, all we got to do is substitute in. So the first one is pretty obvious. So we'll have arc sine, or sine to the negative first, and you stick in a 0. So we'll have 0 over 2, and we know that that just gives us 0. Arc sine of 0 is 0, just like sine of 0 is 0. So arc sine of 0 is also 0. The next thing that we do is we substitute in the square root of 2. So this time it'll be the square root of 2 all over 2. In our case, that just gives us theta is equal to sine to the negative first, or arc sine, of 1 over the square root of 2. Okay. So what is arc sine of 1 over the square root of 2? Well, remember that the range for arc sine is going to be negative pi over 2, comma positive pi over 2. And what I do know is that sine of pi over 4 is 1 over the square root of 2 if I do sine of pi over 4. So if sine of pi over 4 is equal to 1 over the square root of 2, then that means that arc sine of 1 over the square root of 2 would just simply give me pi over 4. So we've effectively changed the limits, and now the integral has become 4 times the integral from 0 to pi over 4. And it's just simply going to end up being theta in here, so we're integrating d theta. So obviously this just becomes 4 integrating d theta, so that's just theta evaluated from 0 to pi over 4. So this just essentially gives us 4 times pi over 4, which is clearly just pi. And so therefore, our final answer here was 4 over the square root of 4 minus x squared with respect to x. So our final answer for this definite integral is simply pi. And that's that. So if you're still struggling with trig substitution, like I said at the beginning of the video, please check out my videos on that. Trig substitution is very important and is extremely confusing at the onset. So please go back and check my videos on that. But that's integration practice, example number 19. Let me know if you got any questions. I'll see you next time. Peace.